Okay. So if you remember, we covered the abstract data type last time. Why? Because it's kind of an introduction to object-oriented, because object-oriented programming is based on the idea of abstract data types. Why is that? Because if you remember, we said ADTs works a lot with encapsulations and hidden information. So all of these concepts are used by object-oriented. And we're going to see that. So we're going to go through a quick introduction. So relationship to abstract data type. Object-oriented programming extends the concept of abstraction, as we said, applied to abstract data type like encapsulations. And if you remember, when we gave an example on the encapsulation, we said, for example, class in C or in Java is what? Is an encapsulation device. So that's how it's relating to ADT in this case, for example. Now, commonalities among similar abstract data types are extracted into new types. Again, you can have subclasses and classes, all of these things. The key feature, so we have two key features. The first one in the object-oriented, we're going to be inheritance. So inheritance is going to be what differentiates from the normal abstract data types. Okay, when it comes to object-oriented, we're going to see what. So inheritance is what? It's a new type, serves as the base for a collection of similar types. Okay, so I have, let's say, class animal, that's the type. And then inside it, I'll have, for example, dog, cat, all these are subclasses. So they can inherit from the main base class. These types inherit common features from the base type. Inheritance is central to object-oriented programming. Now, the other thing, which is very important, the other main feature when it comes to object-oriented programming is dynamic binding. Now, again, at this point, I remember maybe a few chapters ago when we said dynamic and static, people were still confused, right? That's fine. At this point, right away, when we hear dynamic binding, what does it mean? So binding is when we bind the variable or something in memory. So at which time this is going to be bind? Michael, runtime. So do you see now? We didn't even explain it. Dynamic binding, that means runtime. Now, before we even explain it, just using the knowledge from previous chapters, how can dynamic binding, which is binding on runtime, be connected to object-oriented? In which way? Like, when would this dynamic binding happen? Because I'm assuming, as I asked, all of you already took object-oriented class of Java. How can you relate it before we even explain it? Michael.
For the concept of polymorphism?
Very good. Actually, dynamic binding it gets applied, the concept of dynamic binding gets applied using polymorphism and object-oriented. Why polymorphism? Because in polymorphism is what are you doing? You're defining, for example, you have a function in the main class that you can override. Now that means you're not going to actually bind this function in memory until you execute until you run the code and you know which one. So we're going to see an example, but very good, Mike. So dynamic binding of method calls to methods is a fundamental characteristic of OPP. This chapter explores how dynamic binding works in OOP languages. Three main things in the book that's covered when it comes to object-oriented programming was the abstract data type, which we already covered, and inheritance and polymorphism. That's the main focus of the chapter in the book. So why inheritance improves productivity? We're going to start first with inheritance. Why inheritance improves productivity? If I want to relate this, to connect this with ADT, because someone is going to say, okay, we already took ADTs in chapter 11, and we saw the power and the benefit of ADTs. Why do I even need to learn about this? Because inheritance improves ADTs. How? Abstract data type, the power of it is what we said, for example, you have one abstract data type that can have multiple implementation or something, correct? It can be encapsulated, it can be hidden. But what is missing yet? Inheritance will allow you to what? to reuse these abstract data types, right? So instead of having abstract data type like this, like for example, abstract data type of animal, and then abstract data type of dog, abstract data type of cat. Okay, the animal eat and make a sound. Now you have to also define these in the abstract data type of the dog. Also, you have to do it in the cat. So abstract data type is very good, but when you add inheritance to it, what are you doing? You're improving it because you can reuse the code right away. So ADTs are hard to reuse as they need constant modification. So each time you want to reuse it, you have to change something in it, correct? Because why? Let's say you define, I don't know, abstract data type of student, and then we want to have subclasses of university student or school student, for example. If you want to include both of them in the main ADT, you have to modify the main ADT. But with inheritance, you don't have to modify the main ADT. You can just add extra function and under the subclasses. So the ADTs exist independently without shared relationships. So that's the main thing. So the inheritance will improve this. We'll add to the ADT when you have relationships between other ADTs. So what inheritance does enables creation of new classes, which are called subclasses from existing ones. Okay. Reuse ADTs with minor adjustments. Simplify class structure using hierarchical approach. So reuse is the main one, is the main thing that we want to focus on. Also the hierarchical approach, which is what? Based on parent class, child class, all of these things. An example of inheriting, guys, I'm sure you're familiar with this. So as we said, for example, animal, it has void eat in it. Function eat, this animal eats food, and then dog extends animal. That means this subclass that you can actually use the eat from the ADT from this animal, but also you can what? Just use the bark here. Now, if it was a pure ADTs, let's say you want to now include dog inside the animal, what are you going to do? You have to modify the ADT animal to include void eat and void bark. You have to modify it each time to be general. But in this case, with inheritance, you don't have to modify every ADT. You can just use the concept of inheritance. Now, just few concepts terminology-wise, moving from abstract data type to object-oriented programming is what? ADTs. Now we're going to call them classes. Okay, so each time we say this is a class, what are you thinking about? Encapsulation, hidden information, all these kind of things. Class instance are objects also. Class inheriting are derived class or subclass. So both of them are the same thing. Parent class is superclass. Operations or objects can be methods. So just these terminology, if we use them interchangeably, are the same. Now, very quickly, message protocol. Messages are method calls to objects consisting of what? The method name and destination object. The entire collection of methods of an object is called its message protocol. So we're not going to focus a lot on it. The simplest case, guys, is that the class inherits all of the entities of its parent. So that's the simplest one, is that just you have a subclass that will inherit everything. So that's the simplest way. Now, as I was mentioning before, every slide that has this, that means that's what is part of the final. And the final, I have a couple of questions about the object-oriented. These slides that have this yellow and the title, that means these are the ones that are going to be covered directly into the file. So access control and inheritance. Now, access control is one of the most powerful things. And when we talk about the object-oriented concept, you're going to see how some languages, when they design the language, they focus a lot on the access control. Some other languages, no, for example, they didn't focus. So this is one of the design decisions that you have to take. So what are the access control when it comes to inheritance? If you can, we talked about it in the abstract data type. We said, how can we hide, for example? Michael?
Public, private.
Exactly. For example, public, private, protected. So these are what? These are access control. You're controlling the access when it comes to your class. Do you want to give full access, or you want to keep some stuff private that you cannot use and other things? So Private, hidden from all subclasses and clients. Protected are visible to subclasses, but not to clients. Okay, so in the protected, it's visible to subclass, but you cannot use it directly in the main. You have to use it through the subclass. And then you have the public, which is accessible to all. Now, yes?
They're referring to clients as just the main method.
The main method, yeah. Okay. So that's only the client. We're going to see some examples, if not here, on in the review session. Okay. So now, what do we mean by overriding methods? It's one of the main powerful thing when we said about object-oriented, and we kind of mentioned polymorphism, right? So overriding is a subclass can redefine a parent class method, okay? A parent's method is overridden and subclass method overrides. So let's take a look here. We have a class parent. This have private method, protected method, as you can see. And then we have here inside the child extends parent, that's a protected method here. And then inside here, I'm creating a new object, child, which is this one here, and then c.protected method. Now this protected method, I have it defined here as a child, but also it's in the parent. So if I do this, if I define the protected method also here with the same name, what's going to happen? I'm going to be calling this one, it's overridden. So the output would be what? Protected method overridden is child. This one would be the output. So that's overriding. I'm sure you're familiar with it when it comes to Java. Now, from the slides of the book, the 3 ways a class can differ from its parent. The subclass can add variables. So of course, as we said, the simplest way is just to inherit everything, but actually you can add different things, as we saw in the example of the animal and dog. Subclass can modify the behavior of one or more of its inherited methods. The parent class can define some of its variable or methods as also private access. Like if something in the main parent class is private, you cannot access it in the main, for example. So now another difference between class variable and instance variable. I think you've seen this in Java, right? So what is the class variable? How do we define it usually? That means this variable, if I do a class variable, what does it mean technically? That means this variable is going to be supported in all the classes, right? Like on all the subclasses. But instance variable is what? So what?
Multiple
Very good. So technically is what, guys? Usually, how do you create objects of the class? Each time you create a new object, it will have its own instance variable. Okay? But the class variable will be the same for both. Now, if I want to connect this to previous chapters, what does this sound like? What? When we used to define some stuff in C++ examples, for example, as something, like for example, in the recursive example that we gave, we said, Kevin,
Static.
very good. Do you see everything is connected? When we are learning the concepts of programming languages, all these concepts are used through everything, right? So the concept here is what? Class variable. If you want it to be 1, it has to be static. That's why you have to even declare it using static. That this is what fixed. Shared across all objects of the class, but the instance variables, no, each object will have its own one. So it's unique to each object. And then the methods are the same thing. So if you have a class method and then instant methods are the same idea. So if you want to see an example here, guys, so class variable shared by all instances, if I ask you, is this class count? Is it a class variable or an instance variable? You're going to say what? Class variable. And it's very easy to know because of the static. It's very easy, like you don't even have to think about it. So now let's take an example here. I have this class counter. I have a static int class count that starts with 0. And then I have the instance count, which is a instance variable. And then the void increment, if I call this function, it's going to increment the class count and also increment the instance count. So what's going to happen? If I'm calling, first I'm creating two objects of the same class counter, okay? And then I'm saying counter1 don't increment, counter1 don't increment. What should happen? So if I'm calling this counter1 dot increment, that means I'm calling this. What should happen technically? Will default to Michael. So counter dot increment, that means I'm calling this. So what's going to happen? Just we're going to increment shared class variable, increment instance. So we're going to increment both of them. So what should happen? The first one, what would be my instance count? 1. Very good. And when I do it, another one is going to be what? 2. Very good. Now, if I do counter2 dot increment, what's going to happen? The instance count here is going to be 1. We didn't mention anything about the class count yet. So let's see first the outputs of the counter1 dot instance count. Let's see what will be the output here. For the first one, for the first count, is going to be 2 because I called it twice, so this updated twice. Now, the counter2 is going to be 1 because I only called it once, so it increment once. As you see, they are instance variable, they are different. What would be the output of class count, which is a class variable? What would be the output? Yes? 3, exactly. Class count 3, because when I called this the first time, it updated the class count. Second time, updated. Even when I did the other object, updated the same one because it's static. That's the idea of the class variable. Again, it's the same idea that we talked about in the C++ when we define static and all these kind of things in memory. Static, we have this specific fixed memory for it. It's always here, so it's going to always be updated. Very good. Now, another thing, it's single versus multiple inheritance. So if you want to remember from your Java course, does Java support multiple inheritance or not? You have yes, you have no. Michael?
But supports like interfacing, but not multiple inheritance.
Very good. Okay, so we have yes, no, yes, no.
They need to, but they try to block it.
So actually, Java doesn't support multiple inheritance in a direct way. You can do it in an indirect way. We're going to see why, actually. So single inheritance is what? Is a subclass inherits from a single parent class. It's very obvious, simpler, and avoids conflicts. So that's the idea. It's very simple. There's no conflict because you can only inherit from one class. But multiple inheritance, it can have what? Multiple parent classes. The disadvantage of this is what, guys? What is the problem? If I want to talk about it from some terminology that we've learned before, I'm inheriting from, so think about it like this. I have this class A that supports function called eat. Class B also support function called eat. They are different, so different classes, but they have the same exact function, the same exact methods. And then now I have this subclass that inherits from both. So when I'm calling eat, which eat I'm calling? This takes us to what? If I want to think about it from a BNF grammar, parse trees and stuff. Annika is saying ambiguity, which is, that's exactly. So this will make things ambiguous, correct? And that's also, we're going to see it in one of the design things, design issues, all of these kind of things that, okay, would you allow your programming language to support multiple inheritance or not? What is the benefit? Okay, here I'm reducing ambiguity, here I'm whatever, okay? So if I have like more ambiguity in this, that means it's harder to maintain because I have to track them back. So maintainability will be reduced. So there is a decrease in maintainability because of the interdependency created among classes, which is based on the ambiguity. Okay. Now, this is a C++ example. Michael, are you covering inheritance and stuff in the advanced? Oh, okay, very good. So there is a few differences we're going to see. But look at this. How does C++ solve the ambiguity in multiple inheritance? How does it solve it? Yes.
Virtual classes.
Very good. So you can have the virtual classes, and also they have these things. So when you do the 2 points, I'm not sure what's the official name for it, or so that when you do the 2 points, you're specifying which function you want. For example, I'm saying class C, it inherits from public A and public B, from both classes, correct? But I'm saying, if I say A, and then show, that means I'm specifying that I want to call this show here inside A. And if I specify it like that, it's going to call this one, okay? So it avoid, now, if the void looks like this, so if here I didn't specify it, I didn't say A, 2 points, show, or B. If I just called this, what's going to happen? The compiler will not know. Ambiguity, the compiler will be confused. I don't know which one, so we're going to have an issue. That's why the A and B are explicitly called to resolve ambiguity when it comes to C++. Now we're going to see that in Java, multiple inheritance is not allowed directly because of this issue. And this is not something surprising for Java. Why? There's many things that C++ does and allow, Java doesn't allow. For example, type checking, strong typing. All of these, Java says, you know what, I want to try to catch most of the stuff at the compile time. I want to have it like more stricter language to detect errors in it. So without explicit calls, the compiler would not know which show method to call. And as we said, in Java, multiple inheritance of classes is not supported directly to avoid these conflicts. So this is one of the design decisions that, for example, the Java designers took over this issue. Now, we talked about inheritance. The other main feature when it comes to object-oriented, we said it's dynamic binding, okay? And as Michael said, when it comes to object-oriented, it can be done through polymorphism. So a polymorphic variable can be defined in a class that is able to reference objects of the class and objects we're going to see. And then when a class hierarchy includes classes that override methods and such methods, so this is the overridden that we talked about, we're going to also see it. And then we're going to talk a bit about the abstract method and abstract class. So these are from the slides of the book, and then let's talk a bit. So what is a polymorphic variable? Because dynamic binding is going to use the polymorphic variable usually to do the polymorphism, a variable that can reference objects of the declared class or object of any of its descended classes. So in Java, I think they are called differently than C++. This will enable flexibility in referencing different object types. Now, dynamic binding is what? When a class hierarchy includes classes that override methods. So as we said, you'll have a method in the parent class, and then if you're calling the same exact method name and your subclass is going to automatically override it. Correct? And then some other times, like Kevin mentioned, for example, we're going to have a virtual methods. These virtual methods kind of like force you to override them. Why? Why, like if you have a virtual method in the main in the parent class, most probably you're going to override it. Because usually in the parent class, if you have a virtual, it's not defined, right? Like there's a default value for it. So it kind of like force you to override it if you want to have an actual value. It's one of the purposes, of course. So now methods are called through polymorphic variable. The binding to correct method is determined at runtime. So that's the main thing, as we were explaining. Now at this point, whenever you hear the word dynamic binding, you know that we're talking about runtime, not talking about compile time. So this ensures that the correct method implementation is invoked based on the actual type of the object being referenced. We're going to see an example. So what would be an advantage for this? Maintainability. Maintainability is one of the main advantages. Why? Because it facilitates software system that can be more easily extended and maintained during development and post-deployment. So let's see. Here in this C++, for example, I have a virtual method here for dynamic binding. So what will happen here, guys? If I have class animal sound, here it's the same exact name sound is going to override the class animal. If I have another one, same exact one is going to override this. So this is kind of like polymorphism. In Java, there is another way to write this, of course, but this is a C++ example. So as we said, usually in the main, what will happen, you can actually write something like this with the pointer thing, the address, and then if you define a polymorphic variable, what's going to happen now if you want to add the class dog and cat? Because you use this, you have to use the address symbol. Okay, so animal now is equal to what? So this animal here that we created is going to be talking about this class. So when you're calling this animal, you're going to be referring to the one that was overridden. We're not going to go into lots of details of C++ and Java implementation, but you get the main idea of the override. I gave this example, so I'm trying to give more example in C++ because the majority already took Java, so it's good to be familiar with C++, and you're going to actually have the advanced C++ course soon. And this is the one with the cat. So now, what are if you want to continue of the dynamic binding concept, an abstract method is what? An abstract method is a method that defines a protocol but does not have an implementation. That's why that's when we use the virtual. So the one that we saw. So it acts as a blueprint for derived classes. Why is this good? So this is an abstract method, right? An abstract class is what? If you have at least one virtual method, which is an abstract method, if you have at least one, it will make your class called abstract class. So what is the benefit of this? If we want to focus on this, it acts as a blueprint for derived classes. What is one of the benefits? Samuel.
Where we can define a contract with other functions, like I provide this stuff, but we let implementation classes do it differently based on what is better.
Good. So more organizing. So you're organizing your code or your classes in a better way. Any other? Michael.
Checking or like the signature?
Yes, you can also say this. Yeah.
Forces you to instantiate subclasses. You can't directly instantiate the parent.
Also. Anyone had this? Yeah.
Helps with reusability.
Reusability also, yes, if we want to link it to what we covered in the beginning of the lecture. Very good. Guys, imagine you're having this parent class, correct? And you're allowing your subclasses, each of them to use, for example, different method. It's the same thing, but they are different. For example, one has like, I don't know, sound, one has sound with S, plural, one has, for example, you know what I mean? So this is by itself, if you give the blueprint, just from what we said, Samuel, the organizing, if you're just giving the blueprint that, okay, this is the function that you need to use in your subclasses. But you can define whatever you have inside them. I don't have to define it for you, okay? So a class that includes at least one virtual method is also called an abstract class, cannot be installed directly, used to enforce a common interface for all derived classes. So used to enforce a common interface. So that's one of the main thing that I was saying. That means is what you're telling your subclass, you have to use this interface. Don't, like, for example, we have a parent class car, okay? And I don't want, like, for example, if I have a subclass Toyota and subclass BMW, each one are referring to the wheel as a different name. If I define, for example, whatever the wheel as this specific name, then all the subclasses will use the same interface, for example. Think about it like this. Now, the purpose encourages polymorphisms by enforcing a contract that subclasses must adhere to, and then helps in designing modular and scalable systems. Now, this is an example. So that's a pure virtual method, makes this class abstract. Because I have this virtual method here, then now I can say this class animal is abstract class. So no implementation must be defined by derived classes. So now when I call this subclass, I can use this. So declare the sub abstract because it contains a pure virtual method. A pure virtual method is one without implementation. Because as you can saw in this past here, we had it virtual, but it has an implementation. That's not pure virtual. Pure virtual means this. It will have no implementation in it. It has default number or something. Okay. Now, we're going to talk a bit about the design issues. As usual, we're not going to cover all of the design issues. There is many. So, for example, the exclusivity of objects. What do you mean by that? Do we want our language that we're designing to have pure objects only? You cannot use anything other than objects, or you want to allow it objects and primitive. Then our subclasses, subtypes. We're going to see what do we mean by subtypes. For example, single and multiple inheritance. We talked a bit about that. So that's a design decision we have to make. Am I going to allow multiple inheritance? And then object allocation and deallocation. There's also, if we want to have dynamic and static binding, and then there is nested classes. There is also other design issues. We're going to talk about a couple of these. So let's start with the first one, which is the exclusivity of objects. Now, with the languages that you know, I think, for example, Java and C++, what do you think? Are they pure objects oriented or no? Let's start with Java.
Define privilege.
And Java. What about C++?
Definitely not only OOP, it's very imperative too.
Exactly. So now, Java is more close to pure, more close from than C++. C++ is definitely not. Java, they have their own way to use primitive using wrappers. So they have the way to use the primitive using wrappers. Why this is important for C++ and Java to not be pure object, we're going to talk about. So some object-oriented languages enforce that everything in the language must be represented as an object. And we're going to see that Smalltalk, actually, which was the first of purely object-oriented programming, everything was just objects. Other languages, example C++, allow non-object elements like primitive types. Now, should a language enforce exclusivity of objects or allow non-object types for simplicity and performance? That's usually the design question that we're going to answer. Now, if I take the everything is an object, if I want to look at it and see if this is a good option or not to have, what are the advantages? Elegance and purity. So a pure object-oriented design ensures consistency. Everything is objects, everything is the same thing. They are going to be treated all the same way. So there's consistency. The other one is simplifies understanding and use of the language, as there is no distinction between predefined and user-defined types. So what does this mean? So there is no distinction between, let's say, for example, you have this thing as a float or double. This is the same as you having your own class. So there is no distinction. So it's going to be, let's say, easier to learn because everything is treated the same. But what would be a disadvantage that we've already talked about in previous chapters? Think about it. If I want to give you a hint about memory allocation, for example, when we said in Java, when we have something related to objects, it's always on the heap. What does this mean? It will consume more time to get to it. Do you see, guys? You're answering now everything by yourself. It's the same thing. So one of the main issues, if I don't have primitive, if I want to do a very simple thing like adding two numbers, it's going to take me more time than actually doing the primitive. So there is a drawback here, because if I want to do simple tasks, it's going to be costly. So performance overhead operations on simpler scalar, for example, addition of integer, are slower because they involve the message passing process rather than single machine instructions. Example, adding two numbers as objects is slower than performing addition directly in low-level imperative languages like C and other things. Now, what would be an alternative to this? Because I found, okay, there is a disadvantage. That's when C++ jump. They said, because, okay, I'm looking at Smalltalk and they have this issue, and especially that C++ comes from where? From C. Where C is what? It's super fast, like it's more like hardware, close to the hardware. So they have this background, so they will not say, they will not tolerate this issue, right? So that's where imperative plus object-oriented hybrid, like C++. So retain traditional imperative types like int, float, and add the object model. Example, C++, which combines primitive types and objects, resulting in greater flexibility but less uniformity. Now, the other one, which is Java. Java said, okay, I'm going to support primitive, but there'll be like a wrap around it. So there is this thing that they have to do an extra step to support the primitives. So primitive types, example int, are non-objects for performance efficiency, while structure types, arrays, are objects. So there is this mix. And then example Java, where primitives and coexist with objects integer. That's why if you remember in one of the, maybe it was last lecture or something, we said in Java, the difference between C++, you have to actually use integer instead of int in some of the casting and stuff. So now, a summary for this first design issue is what? Pure object-oriented languages offer elegance and uniformity, but at the cost of performance. The hybrid models, example Java and C++, improves efficiency, but increase complexity by mixing primitive and object types. So this is in summary. And this is from the book. Now, let's move to the other design issue. Are subclasses subtypes? This is another one that you have to decide. So what do we mean? We mean what? Do I want my subclass to just inherit from the parent, or do I want it to be a subtype? By what? That means it has to follow exactly as the parent. For example, a silly example, I have class animal, and then a subclass would be what? A dog. Would I allow another subclass called robot dog to be to inherit? Robot dog doesn't have, many of the behaviors are not the same. They don't eat, they don't drink, you know what I mean? So they are different behaviors. They still can inherit, they can be a subclass, they can inherit, but they are different behavior, right? Okay. Now from a more practical programming example is that, okay, if I inherit a function that takes integers or ints as input, I inherit the same function, but I change I allow it to take double as input. This is not subtype anymore because I changed something in it. Okay, now one of the design decisions has to be made. Should I allow this to happen or no? It has to be everything has to be the same exact thing. No. So this is another design. A subclass becomes a subtype if it maintains and is a relationship with its parent class. This means objects of the subclass must behave like objects of the parent class. They have to have, for example, same type, same. Why is it important to maintain the is a relationship when creating subclasses? And then these are questions that's asked on the design decision to make. And what happens if a subclass adds behavior that conflicts with the parent class's intent? And can a subclass inherit implementation but not be a subtype, like the example that I gave? So should I allow it to inherit, but even if it's not a subtype, why and why not? So these are the questions that they will ask for this design issue. Now, what is a relationship? A derived class must be able to function as its parent class without breaking behavior. As we said, for example, this method, output this specific type. It should be the same type, for example, same behavior. Example, a dog is an animal, so dog can inherit from animal. Subtype behavior is what? A derived class subtype must add new functionality without breaking inherited behavior. Override methods in a way that maintains compatibility with the parent class. So this is important. So because you want to override, but you need to maintain the same behavior. When you add new functionality, you shouldn't break the behavior. And then implementation versus interface. So subclasses inherit the parent class's implementation. Subtypes inherit the parent class's interface and must conform to its behavior. Okay, so if something is subtypes, the interface need to also be the same exact thing. So it becomes a subtype. But a subclass doesn't have to be subtype. For example, this is just an example. And if you look here, so we have this class animal. It has sound, it has eat, these two methods, right? So in this case, this is an example of valid subtype. If I do this, void eat, and then I have int food amount, so I'm overriding this, everything is fine. So this is considered what? A valid subtype. Now let's take a look at an invalid subtype. If you look here, if you change, even if you're using the same one, eat, but you're changing it to double instead of int. So in the original one, it takes int as an input. Here, I'm changing it to double. This one doesn't behave the same way. So this is not considered a valid subtype when it comes to the, it's a subclass, but it's not a valid subtype. In this case, if you call the feed animal, for example, you define something feed animal, a robot dog, which is this one, and you pass 10, it's not going to do this. It's not going to print this. It's going to go to the default one in this case. So it's going to go and do the default one here. Anyway, technicalities of C++, we're not going to go into details. So now our subclass is subtypes, incorrect override. As we said, there is an incorrect override, as we explained in the example. So that subtype relationship, the dog class is valid subtype. We said the first one. So the dog class would be considered a valid subtype because it adheres to the is a relationship with the animal, overrides method in a type compatible manner. So when it overrides the method, it kept the behavior, it kept the type. So that's why it's considered a valid subtype, and then maintains the public entities. But when it comes to the robot dog, the other one, it's not valid subtype because, as we said, it fails to override it correctly. The behavior violates the expectation for the client code feed animal. Yes.
So for the robot dog class, if it wasn't intended to override that method eat, and it wanted to overload, so it has still the first implementation, but also the other implementation. Would that be also considered a valid subtype or incorrect?
If it's not overriding, you mean that we're defining also another one, so we'll keep the first one, and this is a different. Now, in this case, I don't think it will still be a subtype because technically the overall behavior from a semantic perspective, not from a syntax perspective, may not be considered a subtype. You know what I mean? Because then that's why we're using a robot dog, because robot is not an actual animal. That's why we use it. So it will be not a subtype, but not from a technical perspective, maybe from a semantic perspective. So why would you say this is a subtype of this when a robot is an animal? From this perspective. Now, the third design issue would be what? Single and multiple inheritance. We said multiple inheritance is what is just like inheriting from more than one class. Now, what is the disadvantage of multiple inheritance? We covered it a bit. Language and implementation complexity, we said, correct? And then we said there is a potential efficiency because dynamic binding costs more with multiple inheritance. Because even if you're just doing one dynamic binding for one class, this is actually by itself is costly. So imagine if you're doing it with 3 or 4 classes. So now advantage is what? Sometimes it is quite convenient and valuable. You need it. As I said, we're not going to go through in details through the other design issues. So the fourth one was the allocation and deallocation of objects. We've talked about this so many times, if you remember. Should we allow this to be allocated, deallocated on a stack or a heap? What did we conclude when it comes to C++? Is it only on the heap, the C++ usually? We said no. This decision is made that you can do it on stack or on a heap. Which one is purely heap when it comes to the objects? Java, for example. So these are like kind of the decision that when you're designing the language, they have to take. So this, if they behave line the ADT, they can be allocated from anywhere, allocated from the runtime stack, or explicitly create on the heap, like we said. And then, or it can be simplified and all be heap dynamic, like Smalltalk is all heap dynamic. Why? Because it's a pure object. And then we said also Java is treating everything as objects, if you remember. So that's why even the primitive are like on the heap. Then if objects are stacked dynamic, there is a problem with regard to subtypes, object slicing. We're not going to go into detail of this. Is the allocation explicit or implicit? That's another one that's related to this. And Java, is it explicit or implicit? In Java, the allocation. Implicit, why, Catherine?
Garbage collector.
Garbage collector, okay? So at this point, we're just reusing what we've learned from before. When it comes to C++, that the allocation is explicit. You need the what? The structure. Yes.
Smart pointers in, oh wait, because I was thinking smart pointers, it does it automatically, right?
Yes, but this is an option. In Java, it's forced on you by the design, for example. It's like always implicit, for example. Yes. Now, another one, dynamic versus static binding. Should all binding of messages to method be dynamic or no, it shouldn't be? So that's another design decision that we have to make. Now, before we go to the support and we go talk a bit about the Smalltalk, the C++, let's do a WOOC lab. Very good. So now we're going to just continue and talk a bit about the different object-oriented programming languages. Are what? Support for OOP and Smalltalk. So Smalltalk is the one before even C++ that was actually made object-oriented popular and all of these things. So Smalltalk is a pure object-oriented language. When we say pure object-oriented language, what do we mean by that? Everything is an object. So everything is an object. All objects have local memory. All computation is through objects, sending messages to objects, and then none of the appearance of imperative languages. So we said even the simplest one, adding two integers, is what is going to be object. So all objects are allocated from the heap. Why from the heap? Because they are all objects. Okay? So all the allocation is implicit, yes.
They say all objects of local memory, that just means that it only exists within the scope of the program, or?
I'm not sure exactly with the Smalltalk, but if it's a heap, that means it's not in the method. Like even if you have methods inside the class, it's going to be also in the heap, not on a stack. Yeah, but I'm not sure exactly how Smalltalk works. To be honest, I've never worked with Smalltalk. All the allocation is implicit, so similar to what? The allocation is similar to Java, for example. Everything is done. Smalltalk classes cannot be nested in other classes. Now, inheritance, when it comes to inheritance, so what is the question that from the design issue, what is the question that we can ask usually when it comes to inheritance from a design question? Would we allow what? Multiple inheritance or not, correct? So a Smalltalk subclass inherits all of the instance variables, instance method, and class methods of its superclass. All subclasses are subtypes, for example. Nothing can be hidden. All subclasses are subtypes. So it seems like in Smalltalk, we don't have the private. You cannot do the private. So that means there is no access control when it comes to Smalltalk. All inheritance is implementation inheritance and no multiple inheritance. Okay, so it doesn't support multiple inheritance. So the one or two or three of the design questions that we asked are covered here. Do they allow multiple inheritance? No. Do they allow subtypes? They said, okay, all subclasses have to be subtypes. Subclass inherits all. Now, what about the dynamic binding? All binding of messages to methods is dynamic, and then the only type checking in Smalltalk is dynamic, and the only type error occurs when a message is sent to an object that has no matching methods. Okay, so now if we want to evaluate this programming language, what can we say? The syntax of the language is simple and regular. Why? Because it's all objects, correct? So everything is object, everything is consistent. So we can say the syntax of the language is simple. Now, a good example of power provided by a small language, but it's going to be slow compared with conventional compiled imperative languages. Why? Again, why it's going to be slow? We've repeated this. Everything is objects. They don't support the imperative thing. If it's object, that means everything's in the heap. Take you more time to get it. Now, dynamic binding allows type errors to go undetected until runtime. Why? Also from previous chapters. Why usually with dynamic binding? The answer is inside this, also in this side. Because of the runtime. Usually, if we have a static binding, that means when you compile, you can detect errors. If you have dynamic binding, it has to wait until the runtime. So this is one of the disadvantages. Introduced the graphical user interface. So that's a good thing about it. And then also the greatest impact was the advancement of OOP. So this actually was a big thing when the Smalltalk came. And then the C++ came after it and became one of the more popular. That's why Smalltalk is not very popular nowadays. Now, support for OOP and C++. Inheritance is what? We said a class need not to be the subclass of any class. Access control. So that's what I want you to focus on. The access controls for members are what? Again. What are the access control?
Public, private, protected.
Exactly. You know it for sure, but I don't want you to see the word access control and you don't know what's access control. If we say access control, that means what? Private, public, and protected. So in the exam, for example, I'm going to tell you, we're going to solve a few questions in the tutorial. Is this method, which is defined protected, as a protected, can be called, and this can be called here, can be called here. You need to know that, okay, protected, for example, is only visible in the class and in the subclass, but not in the client. When we say client, that means in the main thing. So you need to know how this works. Of course, from previous courses, you know this, but if you don't know, practice on it. In addition, the subclassing process can be declared with access control, private or public. That's something also powerful in C++. Why? There is lots of access control. That means even when I'm doing my subclass, I can say if this is a public or private. How? Let's see this. So here I have this base class private, these protected, and then public. When I say class subclass 1 public base class, when I say this, so I'm inheriting from base class, but I'm mentioning that it's public. And this one, that means I can have access to B, Y, and CZ. But if I do this, subclass 2 private base, that means in this one, B, Y, CZ are private and no derived class had access to any of the members. So I'm doing it as private. So there is an extra access control. Again, we're not going to go into the details. A member that is not accessible, do you remember when we said the scope resolution operator, the 2 points, we said why it will solve what? Ambiguity, for example. If you want to have multiple inheritance, you can use them actually to solve this. So a member that is not accessible in a subclass because of private derivation can be declared to be visible there using this. So this also can be used if you have something as private, you can call it and force it to come. So like this, for example. Even if this is private, you can do this, you'll be able to use it. Now, C++, we said multiple inheritance is supported. But what is the problem? You have to actually deal with ambiguity yourself, or else it's going to have problems, as we mentioned in previous slides. So if there are 2 inherited members with the same name, they can both be referenced using the scope resolution operator, this one. And these are, we saw it, that you can have multiple inheritance here. Now, what about dynamic binding? A method can be defined to be virtual, which means that they can be called through polymorphic variables and dynamically bound to messages. A pure virtual function has no definition at all, as we mentioned this. And then a class that has at least one pure virtual function is called what? An abstract class. That's why when we ask the question, what is an abstract class? You can say, okay, with a method without definition. Now, if we want to look at this, we're going to say C++ provides extensive access control. So there is lots of focus on the access control aspect. C++ provides multiple inheritance. And C++, the programmer must decide at design time which methods will be statically bound or dynamically bound. They're going to use the static or, for example, or non-static. Static binding is faster, as you know. Smalltalk type checking is dynamic, flexible, but somehow unsafe. Because of interpretation and dynamic binding, Smalltalk is 10 times slower than C++. So that's why you can see Smalltalk is not used, it's not very popular, for example, as C++ or Java. Because imagine 10 times slower. Like, this is a big, big difference if you want to use it for basic operations. Now, if we move to Java, in Java, there is lots of similarities. So we're only going to mention a few of the things that are different than C++. All data are objects. So that's one of the main things, of course, except the primitive types. And then all primitive types have wrapper classes that store one data value. Okay. All objects are heap dynamic. So that's another difference. We said in the C++ it can be stack or heap. And the finalize method is implicitly called when the garbage collector is about to reclaim the storage occupied by the object. That means the allocation is implicit when it comes to Java. Now, when it comes to inheritance, that's what I asked you in the beginning. Is Java, does it support multiple inheritance or not? What did we answer? Not directly. So single inheritance supported only, but there's an abstract class category that provides some of the benefits of multiple inheritance interface. Actually, so of course it can be supported, but not in a direct way. So an interface can include only method declarations and named constants, blah, blah, blah. You know this from the Java course. Methods can be final, cannot be overridden. So if you have a final, that means that you cannot override this method. All subclasses are subtypes. When it comes to the dynamic binding, what in Java, all messages are dynamically bound to methods unless the method is final. Why unless the method is final, guys? When I'm saying final, what do I mean? No one can override this. That means, would this change at the runtime if no one can override it? That means it's not going to change. So technically, like as if it's like a static. So if it is static, it doesn't have to be dynamic bind. I can just bind it in the beginning and I know it's fixed. So it's similar to the static concept. So static binding is also used if the method is static or private, both of which disallow overriding. So that means the link that we want to do, if you don't allow overriding, that means it's not going to be dynamic binding. And then nested classes. Evaluation of the theory design decision to support OOP are similar to C++. No support for procedural programming, no parentless classes, dynamic binding, use of interface, all of these things. And then we left a summary. Also, this is from the slides of the book. If you notice, there's a C# here and Ruby, because also in the book we cover they cover C# and Ruby. If you want to take a look at the book, but we don't have enough time to go through them. But something good to know is that C#, as previous chapters, you're going to always notice that it always kind of combines the C++, but it adds some of the benefits in the strength of Java, so C#. And that's it. I think we're done. So let me